Good morning, class. How's everyone doing this morning? Okay, so today we are going to do a new lesson. In this lesson, we are going to be learning about the Pythagorean theorem. Now, I know that sounds like a lot. It's a long, difficult word, but I promise this is such an easy concept, okay? So what we're going to do today is learn about the Pythagorean theorem, and we're going to talk about how we use this and why we use this as well. So is anyone in here familiar with this triangle? And can anyone tell me what this triangle is? Okay. Yes, correct. So this is a right triangle. And how do we know that this is a right triangle? Okay, we know that this is a right triangle because it has a what angle? It has a 90-degree angle, and you know that it is a 90-degree angle when you see this little box here on the inside. If you see this little box on the inside, that means that this is a 90-degree angle. Okay, so do everyone get that? Okay, so the Pythagorean theorem is a theorem that we're going to use on right triangles. So you'll know when it's a right triangle, as I've stated, if it has this box here. That box means that this is a 90-degree angle. Okay? Okay, so let's talk about the Pythagorean theorem. The Pythagorean theorem is used to find the missing length of one of the legs, or this angle, which is called the hypotenuse. Okay, so let me write that down. Okay, so this long angle is called the hypotenuse, and these are the legs. Oops, let me, a little sloppy there, but these two angles are called the legs, and this is the hypotenuse. And the Pythagorean theorem is going to be used to find any one of these missing lengths, whether it's one of the legs or whether it's the hypotenuse. So we're going to use this theorem to find out what one of these missing angles are. Okay, so using the Pythagorean theorem, this is going to be used, as I've stated, to find one of the legs or the hypotenuse. Okay, so now we're going to talk about the formula for the Pythagorean theorem. Now, the formula is very simple. It's not anything hard. So I'm going to write the formula down, and the formula is going to be a squared plus b squared is equal to c squared. Okay, so this is the formula for the Pythagorean theorem. The A and B are going to be your legs, and the C is going to be your hypotenuse, okay? So depending on which of these letters have the length to the side, you're going to plug those numbers into the corresponding letters in the theorem, and then you're going to use that to find the angle of the missing letter. Okay, so we're going to do an example, okay? So I'm going to plug in some numbers for one of the sides, and I'm going to leave one of the other sides missing. So we're going to use the theorem, the Pythagorean theorem, to find the angle, well, the length of that missing side, okay? So I'm going to do, let's see, I'm going to do 3 here, and then I'm going to do 4 here, okay? So the hypotenuse is going to be the side that we are going to be looking for, okay? So we're going to plug the 3 and the 4 into A and B, and it doesn't matter which numbers you use for which letter. It's going to be the same regardless. So you can put 3 square plus 4 square, or you can put 4 square plus b square. It doesn't really make a difference. So you're going to plug those in, and then we're going to find out what C is. Okay, so as you can see, I have plugged the numbers into the formula. So we're going to do 3 square plus 4 square is equal to c square. And is anyone familiar with exponents? Okay, so exponents, if it's squared, you're gonna do that number times that number. So 3 times 3 is going to give us what? Exactly, it's going to give us 9. And we're going to add that to 4 square. 4 times 4 is, that's going to be 16. And then we're going to equal c squared because we're trying to find out what c squared is. So you're going to bring that down. Okay, so the next step that we're going to do is 9 plus 16, which is going to be, correct, it's going to be 25. Oops, yeah, 25 is equal to, let me move it over a little bit, c squared. Okay, so now this part is going to get a little tricky because you have the 25 on one side and then you still have the c squared on one side, okay? So now what we're going to do is we're going to try to get the c by itself because we want to find out what c is. And the only way you can get c by itself is if you do the square root of each side, okay? So in order to remove this square root from this c, we're gonna have to do the square root of 25, and then we're gonna have to do the square root of c squared, okay? Is anyone familiar with the square root? Okay, so the square root is pretty much just working backwards from doing squares. So you know how with the squares you're doing 3 times 3? Well, we're pretty much gonna go backwards. So the square root is pretty much telling me what times what is gonna give me 25. So what number times that number is going to give 25, and what times what is 25? Correct. The answer is going to be 5. 5 times 5 is going to be 25, okay? And then when we do the square root of a squared number, that cancels out that square root. So we're going to bring down the c. And look at that, we just solved our first problem. Our missing length for c is going to be 5. See how easy that was? That was super simple. It's super easy, you guys. There's nothing hard about it. I know people get a little frightened when they see this word, Pythagorean theorem. It's such a long word. It may seem complicated, but it's not complicated at all. It's so simple, okay? So we're going to try some more problems, and we're going to talk about how you can use the Pythagorean theorem in real life situations, okay? So let's talk about the Pythagorean theorem and when it can be used. So the Pythagorean theorem can be used in a multitude of situations. It can be used in construction, architect. It can be used to find the steepness of mountain and hills. You can use the Pythagorean theorem in so many situations. Like I said, it's a simple formula that's so easy to use, and you guys are really going to grasp this concept in the snap of a finger because it's, like I said, it's so easy to use. But those are some of the situations that the Pythagorean theorem are used, because I know a lot of people in math always say, well, we're never going to use this in real life. But these are some of the situations when you can use the Pythagorean theorem, okay? Okay, now let's take a look at another problem. Okay, so we have this triangle and it has 2 of the sides here labeled, but this side is missing. So are we going to use the Pythagorean theorem to find the missing side of this angle? Yes. No. Okay. Yes, correct. No. So we're not going to use the Pythagorean theorem to find the missing length of this side. Anyone wants to tell me why? Correct. This is not a right triangle. So we cannot use the Pythagorean theorem to find the missing length of this side. What can someone tell me the correct triangle to use the Pythagorean theorem on? This one, and how do you know that triangle is the correct triangle to do the Pythagorean theorem on. But this triangle, this isn't correct, but there is a dead giveaway that lets you know that this is not the correct triangle that you use the Pythagorean theorem on. Yes, correct. The Pythagorean theorem is going to be used on right, let me see if I can draw it from this angle, a right triangle. And as I stated, you will know that it is a right triangle if it has this box here. And this box is just letting you know that this is a 90-degree angle. So you're only doing the Pythagorean theorem on right triangles. This triangle is not for the Pythagorean theorem. It has to be a right triangle. I see a lot of people were confused about that, so we had to touch bases on that again. You're only going to use this with a right triangle. This is an equilateral triangle. That means that all of the sides are equal, all of the angles are equal. So this is not going to be the correct triangle for the Pythagorean theorem. It has to be a right triangle. Yes, okay, so you don't fully understand how to use the theorem. Okay, so we're going to work on one more problem together as a group because we still have some people that seem like they don't know exactly what to do. So we're gonna go over this one more time again, just so that everyone can grasp the concept of how to apply this theorem to the right triangle. Okay, so here's another example of the Pythagorean theorem. And you know what? I'm going to switch this up, okay? So let's put that number here where the hypotenuse is, okay? Okay, so now we're actually missing a leg at this point. So now we're gonna find out what the leg of this problem is, okay? Okay, so now we're going to, let me write down my formula again, which is a squared plus b squared is equal to c squared, okay? So now we're looking for c. Well, no, I'm wrong. Now we're looking for one of the legs. It can be either or, it can be A or B. So, okay, we're going to plug in the numbers to find the leg, okay? The missing leg. Okay, so we're going to do a squared plus, then we have the 6 here. So we're gonna do 6 squared is equal to, we have the number for hypotenuse, which is 7. So we're gonna plug the 7 in for C, and that's gonna be 7 squared, okay? Now, we're going to do the same thing that we did on the last problem, and that is find the square root of these numbers, okay? So we're gonna bring the a squared down, and then we're going to do 6 squared. So anyone knows what 6 squared is? Again, 6 squared is just the 6 times the 6, okay? Yes, that's going to be 36. And that is going to be equal to 7 squared. Anyone knows what 7 squared is? Yes, 49, okay? So 49. Okay, so we have our numbers. Now, things get a little bit different here, okay? Now we're going to we're going to need to get the a squared on its side by itself. So what are we gonna do, okay? This is going back to an algebraic expression to where you're gonna get the number by the variable by itself. So we're gonna have to move some numbers over, okay? So we're going to do what? Since this is a positive 36, we're going to need to subtract this 36 from each side, okay? So we're going to do 36, minus 36, minus 36, okay? So this is going to cancel out, and then you're going to do a squared is equal to 13. Okay. Yes. So now that we have the a squared is equal to 13, let me put that over here because you can't really see it. It's all the way at the bottom. Okay, so now we're going to need to get the a square by itself. So the a by itself. So what do we do to get rid of this square root? We're going to need, I just told you guys what to do. So to get rid of the square, we're going to need to do the square root of each side, okay? So we're going to do a squared is equal to 13, and we're going to do the square root of each side. And then that's going to get the a by itself and eliminate that square. So we're going to do a is equal to the square root of 13. And that is going to be a decimal. Okay, so once we use our calculators to find the square root of 13, we're going to get that a is equal to 3.6, okay? So this missing side to this triangle is going to be 3.6. Do you guys got that? It's so simple. It's so simple, okay? So now what we're going to do is I put some of these problems. Well, actually, what I'm going to do is I'm going to pass out a worksheet. It's going to have about 3 problems on there. And I want you guys to work on this. You can work on it individually, and then we're going to go from there. And then I'm going to let you guys work in groups to see if you guys can figure it out as a team together, okay? So I'm going to pass out some worksheets to you guys, and then we're going to see how you guys do on your own with these problems, okay? And then we're going to go over it together, and then we're going to do some problems in pairs and groups, and then we're going to work on that and go over that together as well. You got it? Okay, great. Okay, so as I'm walking around watching you guys work on your worksheets, I see that a lot of you guys are actually grasping the concept of the Pythagorean theorem. I see a few of you guys need a little bit more work on it, and that's fine. This is a new theory. This is a new concept, so it's okay if you do not get it. Do not fret about that. This is what I'm here for. I'm here to help you guys learn about this, so do not worry. But overall, you guys are doing really great. You guys seem to grasp this concept quickly, and that's great. As I said, it's so easy. Let's see. Yeah, so it's so easy. Great job, you guys. Great job on your participation. We're going to continue to work on this for the next 10 minutes just to see what you guys have going on. And actually, what I want to do is I want to do the groups, okay? I want to do the groups. So I actually want to put some of you guys who seem to be getting it. I want to put you guys with some of the people who still seem to be struggling a little bit, and maybe you guys can work together as a team, and you can show your classmates exactly how to do it, and you guys can work together so that you guys can grasp the concept together. So for right now, we're going to do that. I'm going to continue to walk around to see how everyone is doing, and yeah, so let's get started on that, you guys.